So moving on to example 8 on page 404 of our book. Now they're going to ask us the one thing we haven't yet to solve for, which is the R value. What's the interest rate? Now we've done this in the past, but it doesn't hurt to redo it here again in the future, especially with our compound interest formula. And example 8 says, LeBron is negotiating a new contract. In order to reduce current taxes, he's agreed to defer a $15 million bonus to be paid as $18 million 4 years from now. If his team invests the $15 million now, what is the minimum annual interest rate they will need to earn to guarantee that the $18 million is available in 4 years? And we'll assume that the annual interest rate is compounded monthly. So they're putting it into a pretty nice account that compounds monthly. All right, so let's put in the principles that we know. We know the A value this time. A is going to be $18 million. And rather than writing 18 with 6 zeros, we'll just call it 18. Because the principal, the P, is $15 million. We'll just call it 15. 18 million and 15 million are roughly the same kind of thing, especially when we call it our answers in millions here. All right. Now we don't know the R value. The interest rate, that's the unknown piece, so that's where we're going to put the question mark on. The time, we know the time. It's going to be 4 years, they said. And then it's going to be compounding monthly. So our N value is going to be 12. All right, so now we know everything there is to know. Let's set this thing up. So we know that there's $18 million. It's going to be equal to $15 million times 1 plus the R we don't know, so let's call it R. The N we do know it's 12. And then we have N time, which is 4, and then times 12. All right, so this is our setup, right? We don't know the R value, but we know everything else around it. So let's take this one step further next. We still have our 18. We still have our 15. We still have 1 plus R over 12, but we know that 4 times 12, or we can use our calculator to have it equal 48. Slightly nicer. All right, let's divide both sides first by 15 here so we can get this reduced. All right, 18 divided by 15, that can be reduced down to 6 over 5. So let's call it that. 6 over 5 is equal to 1 plus R over 12 to the power of 48. All right, now we need to take a 48th root of each side. So we're going to go ahead and take looks like a square root and a square root, except we're going to write 48 on the outside of that square root. Now, none of our calculators have a 48th root button. But we have to remember that the 48th root and the power of 1 over 48 is the same thing. So we're going to take 6 over 5 to the 1 over 48 power. Now the good news here is the 48th root and the 48th power cancel each other out, and so what we get is 1 plus R over 12 at this stage. All right, now we're going to subtract 1 from both sides. So this left side becomes 6/5 to the power of 1 over 48. Minus 1 equals R over 12. And let's leave that for just a second here. Let's go ahead and use our calculator now at this point to figure out what we're going to have before we do the final push to get our interest rate here. So now let's bring up our calculator and clear anything that may be lingering. Let's give ourselves some space so we can see what we're writing here. All right, so we're going to use a parenthesis and say 6 divided by 5. Close parenthesis, raise that to the power of 1 divided by 48. Hit enter. Then say minus 1, because remember, our thing is a minus 1 here. So let's get minus 1 on our calculators. All right, that value doesn't mean much to us at the moment, but let's just linger it in the calculator as 0.003. Now, I don't want to delete it off my calculator. I don't want to clear it. All right. 0.003 is what we're going to use to write something down our page here so that we have something. All right, so 0.003 divided by 12. Now, I'm not going to use 0.003. It's just a representation of it. I'm using it because I still have to figure out what R is. And to get R, I've got to multiply by 12 on both sides here. So if I go back to my calculator and I say times 12, that should give me my interest rate, at least a part of it anyway, that we want. So now we say times 12, and it looks like it's 0.04566. So that's the decimal version of it, although they never want the decimal version as an answer. So let's multiply this by 100 to get the actual percentage that we're going to write down as the percent answer. When we multiply times 100, we're going to see 4.5667. So we're going to call this 4.567, 4567, I guess, 4.567%. So what kind of interest rate should the team be looking for to get? 4.567% as the interest rate. And now you can solve for any one of these things. You can solve for A. You can solve for P. You can solve for R. You can solve for N. You can solve for T or the other N. Most times we don't ask you to solve for N, by the way, even though you could. We don't ask that. We have to kind of know the compounding that's taking place here. But T and R and P and A, those are all values that you can now solve for. So try the homework, please.